In order to check the homogeneity or correctness of an equation, we find the dimensions of both sides of the equation. If the dimensions on both sides are the same, the equation is said to be dimensionally correct. You can apply it to any formula and check its correctness. This method is called the principle of homogeneity of dimensions. Now, to understand it better, let's take an equation and check whether it is dimensionally correct or not. We take the velocity equation of a transverse wave v is equal to square root f into L over m. In this equation, v is the speed of the transverse wave on a stretched string of length L with tension F. On the left side, we have velocity. Its dimensions are Lt raised to the power minus 1. Now, the right side of the equation has three terms, F, L, and m. Dimensions of the right side of the equation are square root of f times L times m raised to the power minus 1. Now, the dimension of force is mlt raised to the power minus 2, right? And the dimension of length is L. And for mass, it is m raised to the power minus 1. So, mlt raised to the power minus 2, L, and m raised to the power minus 1 are all under a square. And multiplying all of them, we get square root L raised to the power 2 and t raised to the power minus 2 as m raised to the power 0 is equal to 1. Finally, the answer is Lt raised to the power minus 1 after removing the square root. Now, we see both sides of the equations have the same dimensions, that is, Lt raised to the power minus 1. So, the equation is dimensionally correct.